Hey everyone, and welcome. Today we're going to dive into a really cool topic in chemistry, chemical bonding. Now, I know that sounds a bit serious, but think of it this way. We're going to find out how atoms make friends with each other. It's fascinating.
So that brings us to the big question, right? In the world of atoms, how does this whole friendship ring even work? Well, it's kind of like how we need friends to feel happy and, complete. Atoms are pretty much the same. They're all looking for partners to become stable. Let's break this whole idea down and make it super simple.
Okay, let's start with our first section, an atom's desire, or as we say, atom's kierzoo. So what is it that every single atom, deep down, really wants? And you know what? That desire, that goal, is actually super simple. All they want is to have a full outer shell of electrons. That's it. This one single rule is the key to understanding everything about chemical bonding. Seriously, if you remember this, you've got half the battle won. Okay, so if atoms want a full shell, how do we figure out which ones will give away electrons and which ones will take them? Well, luckily for us, chemistry has a perfect cheat sheet for this. Let's move on to section 2 and talk about our best friend in this topic, the periodic table. See, the periodic table isn't just a boring chart of elements. It actually tells us the personality of each atom. If you look closely here, you can see these numbers above the groups, +1, +2, and then on the other side, -2, -1. This is their valency, and it's the secret code. A plus sign means the atom wants to give away electrons, and a minus sign means it wants to take them. It's that easy. Let's look at a couple of examples to make this crystal clear. Take hydrogen. It has just one electron. So its easiest path to stability is to either give that one away, which we show as +1, or maybe find one more to complete its shell. Now look at carbon over here. It's in a tricky spot. It has 4 electrons in its outer shell, so it could either look for 4 more, a valency of -4, or it could just give away all 4 of its own, a +4. So you see, different atoms have different strategies to get stable. And this whole idea of giving and taking electrons leads us perfectly to our first type of atomic friendship. Let's jump into section 3. Ionic bonds, the world of the givers and the takers. So what exactly is an ionic bond? Well, it happens when one atom, usually a metal, completely transfers one or more of its electrons to another atom, usually a nonmetal. It's not about sharing, it's a complete giveaway. In simple terms, it's a straight-up deal of giving and taking electrons, an electron kalendin. The process is actually super logical and happens in 3 easy steps. First, you have a metal atom that's eager to donate its extra electrons. Then, a nonmetal atom comes along and happily accepts those electrons. Finally, and this is the magic part, after the transfer, the metal becomes positively charged and the nonmetal becomes negatively charged. And what do we know about opposites? They attract. That powerful attraction is what creates the strong ionic bond. And here's the most famous example of this in action. Look at this diagram. We have sodium, or Na, which has 1 extra electron it desperately wants to get rid of. And here's chlorine, Cl, which is just 1 electron short of a full shell. It's a perfect match. So sodium gives an electron to chlorine. Now sodium becomes Na+, and chlorine becomes Cl-. They get drawn to each other and form NaCl, which is just regular table salt. A perfect partnership, right? But what happens when you have 2 atoms and they both need electrons? There's no generous giver in the picture. What do they do then? Well, that's where our second type of friendship comes into play. Let's talk about section 4, covalent bonds, the sharers. So, a covalent bond is formed when 2 or more nonmetal atoms decide to share electrons to fill their outer shells. See the difference? There's no transfer, no giving and taking. This is all about teamwork and cooperation. It's all about electron key sharing. So how does this sharing actually work? Okay, step 1, you've got 2 atoms, both of them are short on electrons. Step 2, instead of one giving an electron to the other, they kind of huddle up and overlap their outer shells. And for step 3, they place electrons in that shared space and share them as a pair. And here's the really cool part. Each atom gets to count that shared pair as its own. It's a win-win that makes both of them stable. Just take a look at this diagram of methane, or CH4. Right in the center, you have 1 carbon atom. Remember how it needed 4 electrons? Well, it finds 4 hydrogen atoms, each with 1 electron to share. So the carbon shares 1 of its electrons with each of the 4 hydrogens. What's the result? The carbon atom feels like it has a full shell of 8, and each hydrogen feels like it has a full shell of 2. Everyone gets what they want.
And this sharing isn't just limited to one pair of electrons. If atoms need more, they can share more. They can form double bonds by sharing two pairs, or even triple bonds. Look at this example of nitrogen gas, N squared. Each nitrogen atom needs 3 electrons, so what do? They get together and share a whopping 3 pairs of electrons between them, forming an incredibly strong triple bond.
All right, we've covered a lot of ground, so now let's switch gears and quickly recap everything specifically from an exam point of view. This is Section 5, Bonding, for your exams. Pay close attention here. Okay, this slide is super important. Let's do a direct comparison. For ionic bonds, remember the key phrase electron transfer. It happens between a metal and a nonmetal, and it forms charged ions. On the other hand, for covalent bonds, the key word is electron sharing. This happens between two nonmetals, and it forms neutral molecules. Please make sure you remember this chart. It's a classic exam question. And finally, here are your absolute must-know exam hot points. First, the whole reason atoms bond is to get a stable full outer electron shell. Second, valency is your guide. It tells you exactly how many electrons an atom needs to give, take, or share. Third, a metal plus a nonmetal will almost always give you an ionic bond. Fourth, a nonmetal plus another nonmetal will give you a covalent bond. And fifth, when in doubt, always look at the periodic table. So we've seen how atoms can either completely give away their electrons or share them nicely. But here's a thought to leave you with. What if a bond is somewhere in between? Not a full transfer, but not a perfectly equal sharing either. It's a question that opens up a whole new, deeper level of chemistry to explore. अगर आपको ये वीडियो हेल्पफुल लगा हो तो प्लीज़ लाइक, शेयर और चैनल को सब्सक्राइब करना मत भूलना। सारे PDFs के लिए मेरा टेलीग्राम चैनल ज्वाइन करें, लिंक डिस्क्रिप्शन में है। Keep watching and stay tuned.